In this video, we're going to look at some more translations of the graphs of sine and cosine. Again, revisiting those two forms for our sinusoidal functions, and these are the same regardless of whether we're using sine or cosine. A equals sine of bx minus c, or y equals a times sine of b times x minus c plus d. So we're going to call this form 1 and this form 2. Again, our amplitude is represented by that coefficient A. B represents our frequency, so it determines the number of periods over 2 pi. So to determine the period of the given equation or the given function, you're going to take the parent function period of 2 pi divided by B. The phase shift is our horizontal shift, and depending on which form we have, you're going to determine the phase shift differently. So if you've got form 1, where the B is not factored out, the phase shift is going to be C over B. In the second form, the phase shift is just going to be C because we've already factored out that value of B. Remember that if we've got X minus C inside the parentheses, this is going to be a shift to the right. We've got X plus C. This is going to shift left. And then D is our midline. We've seen examples where sometimes these coefficients, these variables A, B, C, and D are capitalized. Sometimes they're lowercase, doesn't make any difference. They could be completely different variables altogether. We really do want to be mindful of the position of these coefficients and how they relate to the transformation that we're looking for. So it doesn't really matter if we use A, B, C, and D, or M, N, P, Q, doesn't make any difference. Graph y equals sine of x minus pi over 2. This one's a nice, easy transition into looking at phase shifts. We have no other transformations except for this minus pi over 2 inside the parentheses, which is going to be our value of c. So this tells me we are going to shift pi over 2 units, and because it's a minus pi over 2, this is going to be to the right. And what we're going to use this phase shift to identify is where we're going to start. Thinking back to how we graphed the parent function of sine of x, we started at 0, 0 at the midline, then we went up to the max, back to the midline, down to the min, back to the midline. So that starting point where we began that 5-point pattern, we're going to shift that based on this phase shift. So instead of starting at 0, 0, now we really want to start at pi over 2. So a real quick sketch, we know our graph is going to look something like this. But let's figure out how to set this graph up so that it's not a sketch. We want to have points labeled and have a pretty accurate graph. What I'm going to do is start by marking off the period, 2 pi. And I'm going to start marking my halves for that. Here's pi. That means this is pi over 2, and this is 3 pi over 2. Since the period hasn't changed, in order to graph a full period, if we start at pi over 2, we're not going to end at 2 pi. We're going to need one more point this way, or one more segment to the right. So starting at the midline, at pi over 2, since that's our starting point now from that phase shift, going up to the max, back to the midline, down to the min, back to the midline. We can see that graph there. Now we could have also continued, instead of adding another segment to the right, we could have just said, well, this is gonna be at the minimum here and then continue it that way. Graph y equals -2 cosine of 3x plus pi. There's a lot of different transformations happening here, so let's start making some notes on them, and then we'll talk about how we're going to put these together to graph this picture or to graph this equation. First, that 2 represents our amplitude. And we know that we're going to reflect the x-axis. Since this is a graph of cosine, I like to give a quick sketch of what that looks like. It's going to start at a minimum instead of a maximum. The frequency is 3. So to find our period, it's going to be 2 pi over 3. We can't simplify that, so we're going to leave it just like that. And then our phase shift our phase shift is going to be that coefficient of pi divided by 3, because that 3 is not factored out. So this is an example of that first form. All right, if we go back up here, we're in form 1 here, where that b is inside the parentheses. So that phase shift is going to be c over b, or pi over 3. Now, when we're graphing this, I like to again start with that idea of where's my starting point. So the first thing I'm going to do is determine that starting point. And my graph of cosine, our parent function, we started at x equals 0. Well, instead of just having cosine of x, we've got cosine of 3x plus pi. So we're going to determine that starting point by setting the argument equal to 0. Which is also illustrating that phase shift. For some reason, the idea of determining that starting point operates a lot easier in my head than the idea of trying to process a phase shift. It does also help me indicate, like, where do I begin in these graphs? The next thing we're going to do is mark the period from our starting point. Actually, what we will do in future examples is we'll then start marking the midline of our graph. Because we do not have any value added or subtracted, our midline is still going to be 0. So we don't really need to do anything for this particular example for that. Then we're going to mark the period starting from our starting point. And then we'll look at the amplitude and the reflection, or yeah, amplitude and or reflection. So let's put this all together. Since I do start at negative pi over 3, I'm not going to start my graph quite so far focusing on the right side. I'm going to build some on the left. And I'm just going to mark pi over 3 somewhere to the left. Doesn't really matter how far over. I always try to make my graphs a little bit bigger, because when you start dealing with smaller increments, it gets very crowded. My midline is still 0. Now, my next part, so I don't need to do anything with that. My next part would be to mark the period from that starting point. Our period is 2 pi over 3. So if this is 1 pi over 3 units, going to positive pi over 3 gives me that 1 period. So the different distance between negative pi over 3 and pi over 3 is 2 pi over 3. For our period, we're going to now divide this into halves. So starting with half is going to be at 0, and then halves again. This is going to be pi over 6, and this is going to be negative pi over 6. Our amplitude was 2, so 2, negative 2. And because we have that negative reflection at our starting point, again, we're thinking about these yellow lines bounding 1 period. So we're going to start our curve for cosine at that left bound and end it at that right bound. Because we had that vertical reflection, we're going to start at the minimum instead of the maximum, right? Our cosine parent function starts at the max and then goes down. We're going to start at the minimum, go to the midline, go to our maximum, midline, minimum. And it's still pretty condensed, but that's how we would graph that function y equals negative 2 cosine of 3x plus pi. Graph y equals negative 1 plus 2 sine of 4x plus pi over 2. And we're going to do this over 2 periods. So we're going to repeat the pattern twice. One quick observation, it looks like that vertical shift, the midline value is out front, and that's not uncommon to see it put out front. Let's start by identifying those values for our transformations, and then we'll go through those same 4 steps to help us set up that graph. So our amplitude is the coefficient on our trig function. So the amplitude is 2. Since it's a positive 2, we're not going to have any type of vertical reflection. Our period is going to be based on the frequency, which is 4. So it's going to be 2 pi divided by 4, or pi over 2. Our phase shift, again, we're looking at that form 1 of the sinusoidal function, which is really more common than seeing form 2, but I think it's helpful to see both of them. It's going to be pi over 2 divided by 4, which simplifies to pi over 8. Because it's a positive or plus pi over 2 inside the parentheses, it's actually going to be to the left. And then last, our midline is now equal to that value that's added or subtracted from the function. So negative 1. And actually, we should write this formally. It is an equation, y equals negative 1. It's not really going to be graphed. We're going to use a dash line for that. Again, I like to start by figuring out my starting point. It is related to our phase shift, so you can use just the phase shift to do this. The other thing I like about this process of finding that starting point is that it will help us in graphs of tangent, cotangent, secant, cosecant, where we're actually going to end up with asymptotes, which we'll see in a few videos or in the next video or next few videos. But it will also help us when we're solving equations for trig function or trig equations. So we're going to use this skill again. So I think it's helpful to see it here. But again, it's entirely up to you if you're comfortable with just using that phase shift, or if you want to go through the process of thinking about where are we going to start graphing this equation. So again, that starting point, since our sine function, that parent function, sine of x starts at 0, 0, we're going to find where the argument is equal to 0. Subtracting pi over 2 first, and then dividing by 4, x is equal to negative pi over 8. Again, that does, again, illustrate that we are shifting to the left, not to the right. So I'm going to illustrate these steps as I go. So I'm starting at negative pi over 8. So I'm going to call that negative pi over 8. Step 2, we're going to mark the midline. That midline was y equals -1. So I'm actually going to give myself a little bit of space here. And I'm going to use a different color here just to make it so it's clearly not part of the graph, but helps us see it. Three, we're going to mark the period from that starting point. So our period was pi over 2. We're going to start making some equal width segments here in factors of pi over 8. So here's 0, here's going to be 1 pi over 8, 2 pi over 8, which if I write this out, we can see that that's pi over 4. Three pi over 8, 4 pi over 8, so here's pi over 2. So I'm just marking some of these. And we need to go pi over 2 units to complete one period. Since we are going to graph 2 periods, I'm going to start continuing this sequence and creating a few more marks on our horizontal axis. So there's pi over 2. So again, I'm thinking 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Here's 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8. So here's pi. This was 3 pi over 4. So we can just see that x-axis being sectioned off. So now we need to think about pi over 2 as our period. Well, what is that in terms of 8? That might help us. So pi over 2, if we want to make this 8 in the denominator, we need to multiply by 4 over 4. So this is 4 pi over 8. And what this is going to help me see is I've got my starting point here at negative pi over 8, and I need to go 4 of these pi over 8 units to complete one period. So 1, 2, 3, 4 pi over 8 ends one period. 1, 2, 3, 4 pi over 8 ends the second period. Now the next step 4 is our amplitude and reflection. We did not have any reflection, but we did have an amplitude change of 2. So again, we're starting from our midline. That amplitude is the distance from the midline to the maximum. So the maximum, if we started our midline of -1, -1 to 0 to 1, that's going to be our maximum. And then we're going to have to extend that vertical x-axis or the vertical axis -2, -3. So we know that our maximum is going to be at +1, our minimum is going to be at -3. Thinking about our sine function, sine, we start at the midline, go up to the maximum, back to the midline, down to the minimum, back to the midline. So we are starting at negative pi over 8, and our midline here is at -1. Then we're going up to our maximum, back to our midline, down to our minimum, back to our midline. Oops, sorry, those points are wrong. Oh, yikes, not where I wanted to go. It's going to be hard to erase that point. Here's our midline, minimum, back to our midline here. Now we're back at our maximum, back at our midline, minimum, midline. So that's, again, another example of why it really helps to have that midline somehow denoted on your graph, because you can see even I, reverted back to thinking the midline was the x-axis, which it's not in this particular example. So starting up, going back down, going back up, all the way up, back down, and all the way up. And there's our graph. Okay, another pretty complicated example with multiple transformations. This time we're going to be dealing with cosine. Y equals 4 minus 2 cosine of 1/2 x minus pi. The amplitude is going to be 2. We're going to reflect about the x-axis because of that negative here. So just a quick sketch, if we reflect over the x-axis, that means our sine, I'm sorry, we're using cosine. So instead of starting at the maximum, we're going to start at the minimum. Our period is going to be 2 pi divided by our frequency, which is 1/2, which is the same as 2 pi times 2 or 4 pi. Our phase shift is going to be pi over 1/2 or pi times 2 or 2 pi. And because it's minus pi inside those parentheses, it is going to be to the right. So that first step, what's our starting point? Again, I'm going to take that argument, which I've done in every one of these. I'm setting that argument equal to 0 because that's how we start our parent function, is at x equals 0. So 1/2 x minus pi equals 0, 1/2 x, adding pi to both sides, multiplying both sides by 2, x is equal to 2 pi. Again, that's reflected in that phase shift that we've already identified. So if you wanted to identify the phase shift or identify the starting point, you're getting the same information both ways. For me, for whatever reason, I just process the idea of a starting point better than a phase shift. Oh, I did not identify the midline. Sorry, the midline is y equals 4. It's that constant that's being added here. So let me start putting these together on the graph. All right, so we're starting at 2 pi. So there's our starting point. Our midline is 4, which I'm actually gonna change this up a little bit. Sometimes we end up having to adjust our grid when we get there. So there's 2 pi. That's going to be pi. Our midline is going to be 4. So I'm going to scale this a little bit more narrow. There's 4 and mark that midline. Next, I'm going to mark that period from the starting point. So 2 pi is where our period is going to start. And our period is 4 pi units. So I've already scaled it by pi. So I'm going to go 1, 2, 3. That's 4 pi, which takes me to 6 pi. And this is where my first period is going to end. Now, I could continue to go to the right, or I could go to the left. It doesn't make any difference from that 2 pi. Here's 1 period. I need to graph another period. The directions tell me to graph 2 periods. So I can either graph another period over here or graph another period over here. It really depends on the spacing you have. I'm going to run out of space over here, so I'm going to keep going to the right. 1, 2, 3, 4. takes me to 10 pi. And then this yellow line is going to mark the end of my second period. The last step, we want to start marking our amplitude. So identifying our minimum and maximum values. Our amplitude is 2, so that's going to be 2 units above that midline and 2 units below the midline. So 1, 2, and then 1, 2 is here. So we've got from 2 to 6 are going to be the values for our minimum and our maximum. Since we're dealing with cosine, we're going to start at a minimum. Again, thinking about that shape. We're starting at a minimum. We're starting at this yellow line. So this graph is going to start here at 2 pi, comma 2. Now, moving one segment to the right, we go to our midline. Then we go to our maximum. Then we're back to our midline. Then we're to our minimum. And now we repeat. We're back at our midline, maximum, midline, minimum. And there's our graph. Determine an equation in terms of sine and cosine for the following graph. So in our last video, we looked at, we chose one of our functions we wanted to use. Now we're going to use both just to illustrate that we can write an equation in terms of sine for this graph and an equation in terms of cosine for this graph. So which one do we want to start with? Thinking about that starting point, I'm going to look at x equals 0. It's starting at a minimum. So I'm going to begin with cosine because cosine is not going to require any phase shifts. I'm still going to have to deal with sine, but I can deal with that later. For whatever reason, I want to start with the easy one first. Now, some things we want to pay attention to. Let's start identifying the midline for this graph. That's going to be halfway between the minimum value and the maximum value. So this is 1, 2, 3, 4, 5. So halfway between 1 and 5. Looks like it's going to be about there. So right at 3. So that tells me that D is equal to 3. And that's not going to matter whichever, or it's not going to change regardless of which function we use. From here, we can also determine the amplitude. The amplitude is the distance between your midline and your max, or the distance between your midline and your min. So we can see that A is 2. For cosine, since we're starting at the minimum instead of the maximum, we know we've got that vertical reflection. That's going to make A negative. So I've just plugged in some of the values that I'm already aware of. Okay, my amplitude was 2. Because we start at a minimum, there's that vertical reflection, which makes it negative, and our midline is 3. Now the period of this, we want to look at that starting point all the way till it starts repeating itself. So that's going to go from here to here, which is from 0 to pi. So our period is pi. Which is equal to 2 pi divided by b. Solving this equation for b, we get b times pi equals 2 pi. Dividing both sides by pi, we get b is equal to 2. And since we're starting at a minimum, we don't have any phase shifts. This isn't starting in the middle of one of the curves. So again, cosine, we start at a minimum or a maximum. Sine, we're going to start at the midline. So if we're not starting at a minimum or a maximum or right at the midline, then we've got some sort of phase shift. But we don't have a phase shift here, so this is just going to be 2x. And here's our equation for cosine. Now for sine, we're going to use a lot of the same values because the amplitude's the same, the midline is the same, the period is the same. So going back to this graph, and I'm going to clear up some of this stuff here just so that I don't get too confused. I'm going to think about where sine starts. So sine starts at that midline. So I'm going to think about this point right here being that start where I see it goes up and then comes back down, then goes back up. So I'm going to use this as my starting point, and that's at pi over 4. What that tells me is that C over, well, hold on. Sorry, working backwards. We used that argument set equal to 0 to find our starting point. So if we think about it, we used to set up bx minus c. Well, we know what b is. B is 2. Well, let me write this out. Bx minus c is equal to 0 to find that starting point. And this pi over 4 is that value of x for our starting point. We also know the value of b is 2. So 2 times pi over 4 minus c is equal to 0. And we can solve that for that value of c that we're going to substitute in. 2 times pi over 4 is pi over 2 minus c equals 0. So that tells me that c, if I add c to both sides, is pi over 2. Looking at that starting point, we are going up, so we don't have any reflection about the x-axis. So a is still just going to be positive 2 times sine of 2x. C is positive pi over 2. Or, I'm sorry, C is going to be minus pi over 2, and I'm going to point out why. And then D is 3. The reason it's a minus pi over 2 is because how we set up our equation. So that is bx minus c. So when we solve for c and we're plugging that pi over 2 back in, it's 2x minus pi over 2. And we're going to transfer over to Desmos just to see that these two equations do end up yielding the same picture. So we're back on Desmos now, and you'll notice I cleared out that previous function and I reset this grid. To reset your grid, you're going to see a little bit of a home. So when I move around, see how I've got that home button now? So that changes that view back to our standard view. Sometimes nice to do that. So I'm going to graph my two equations. Y equals, the first one was -2 cosine of 2x plus 3. We can see that graph in purple. The next equation we wrote was y equals 2 times sine of 2x minus pi divided by 2 plus 3. And that graph is in black. It lies right on top of that purple graph. And if we were to compare it to what we have displayed above in our notes, we would see it's the same thing. Now, we would want to adjust the scale of your horizontal and vertical axis to see it a little bit more clearly, but hopefully you can tell that we did successfully write two equations, one in terms of cosine, one in terms of sine for that particular graph.